Hello, we're going to be taking a look at this problem, maximum number of books you can take. So we're given a indexed array of books where the ith book denotes the number of books on the shelf. And we want to take a contiguous array of, or a contiguous section of the bookshelf. And for this contiguous section, we want to take strictly fewer books from I to I plus 1. So we want to go from, if we have 8 and 5, we want to go up. So in order to go up from 8 to 5, we have to go down to 4, and that will fit our strictly increasing criteria. So with this example, we want to take a look at 8, and the way we can look at it is we can look backwards to see if there's something less than for us to make a strictly increasing triangle. So we don't see anything here, but we can still make a triangle. And with this triangle, we'll have 8, and we'll have another triangle down here, which is 7. So to calculate this triangle, we're going to use Pascal's triangle formula, which is n times n plus 1 over 2. So it's going to be 8 plus 9 over 2, which is 36. We want to subtract it from the 7 triangle here, which is 7 times 8 over 2, which is 28. And that's going to give us 8. So we store this triangle section, in a stack. But we want to store the index. We're going to store the index, and we're going to store a DP table for the value. So now let's look at this. We'll look back and see if there are valid values in the stack. So everything has to fit in this triangle. If not, it's invalid. So this is invalid. Pop it from the stack, and we'll make a new triangle. 3, and that's in our stack. So this is a triangle of 3. And let's look at this value. 3, let's look back. Okay, there are some valid values in the stack, which is an existing triangle. So we're actually going to need to store this entire triangle minus this triangle. That's going to be 6, which is this triangle, minus 3, which is this triangle. So we want to store this section of the triangle. Here we're calculating this section of the triangle, and we're adding the last stack value, which is 3, this triangle. And we can store that on our DP table, and this in our stack. And let's look at this value, which is 7. Take a look back. And there's a value here. So we'll have to calculate the triangle from here to here, which is triangle of 7 minus a triangle of 6. So triangle of 7 is 7 times 8 over 2, which is 28, minus triangle of 6, 6 times 7 over 2 is 21. So 28 minus 21 is 7. And we could add 7 to the last value in the stack, which is 13. And we can store that new triangle here. So this triangle is this plus this section, which is this section. And for this 3, take a look back. We see this 3 invalidates. So since it doesn't fit in this triangle, so we can delete this and this. Since this extends out the triangle, and index 1, this is outside the triangle, so we want to move that from the stack, and then we can calculate a brand new triangle here, which is 4. So that's a 6 on this DP table. I'm going to check 4 here. Look back. Nothing to invalidate. This triangle is valid, so we'll do this triangle minus this triangle because we just want to get this section. And that is 4 since it's just 1 here. And then we'll add the last good triangle. It's going to be a 10. So that on this side. So we get a 0, and this there's no triangle to be made, so we can invalidate everything. And 1 here. It's just a 1 triangle, nothing behind it. So we can just store that. Triangle here plus 4 is 5. And 3, looking back, this 8 is invalid, doesn't fit within this triangle. So we'll have to calculate this triangle minus this triangle, which gives us this section here. So it's 3 times 2 over 2, 3. Here. It's gonna be 3 times 4 over 2, which is 6. Minus this section. Minus 1 equals 5. So this section is 5. We're gonna add the last good value here, which is a 1. And that's gonna be a 6. Alright, let's solve this problem. We're going to need a stack of indices and a DP table. And we're going to iterate through the books. So we want to get the triangle value of each book. Get triangle value. And for each triangle value, you want to compare it to the last stack value to get a subsection. So last good triangle index is top of the stack. And the lesser triangle to get the subsection is the current index minus the stack. Last good triangle. Index. So we want to subtract by the lesser good triangle index. is minus that index. How do we add by? Oh, that's good value. Otherwise, we want to get the fake triangle. So we have a 5, 4 triangle here. There's a -1 triangle with 3, 2, 1. So we're gonna subtract that out. Minus the code index. So 5 minus 2 or minus 1 minus 1. So you get -1. And then we can sort of have a table and check our ANSI. And then store it on our set. And we want to invalidate the triangles. So, triangles. We want to check the top of the stack. So that value, that's greater than or equal to our possible subsection lesser triangle. So this part, that's going to be minus 9 minus stack up. In the proper stack. Oops. Okay. 7. So let's walk through. 7, 3, 7, 12. So we got 11 here. So this triangle's not registering. So let's walk through 7. You will store the 7 value on DP0 and then push 0. And 0, it breaks the stack. And we'll move to 3. And there's nothing in the stack because it broke. So push 2 on the stack. And 4. Wait, 4 minus 3 minus 0. The triangle value of 0. 0 plus 1 over 2. 0 plus 1 over 2. 0 plus 1 over 2. That might give us positive value. So leave. Yeah, so leave 0 was giving a value here. Which is causing an issue with our stack. Yeah, that's the answer. Let me know if you have any questions.